We're going to go over integration by change of variables. Now we use this method of integration when we are integrating linear functions which are multiplying and they are raised to a certain power or even not. So as long as we've got linear functions multiplying a product of linear function, we're going to use change of variables method. So we're going to just get inlet and equate to the one which is a bit complex or the one which is in the brackets or something. So let's use u. So let u be equal to 3x minus 2. I'm only getting what is inside. So we're going to find the derivative of u, and that is going to be just the derivative of this. That would be 3. So it was supposed to be du over dx, but I'll put dx this side. And I'll make, okay, what I'm going to do from here is I'm going to make x a subject of the formula. So I'll take it from here. I'll take it to the other side, so it will be u plus 2, and that will be equal to 3x. So dividing both sides by 3, x is going to be u plus 2 divided by 3. And so this is what we're going to do. We're going to go on and replace in that function, and at the same time let me make dx subject the formula. That is going to be du divided by 3. I'm simply dividing both sides by 3. Dx will remain alone, and so that it will come down there. So we are saying the integral of x, 3x minus 2 to the power 6 dx, is going to be equal to the integral. Where there is x, we are replacing with u plus 2 divided by 3. And where there is 3x minus 2 to the power 6, we are putting, where there is 3x minus 2, we are just putting a u, and that is raised to the power 6. Where there is dx, we are putting du over 3. This point we can multiply this 3 and this 3, that will give us a 9. So we have got a 9 in the denominator, and that's a constant. We can take that outside the integral, and that will just remain u plus 2 and then u to the power 6 du. So from there we're going to get 1 over 9 integral. I'm going to multiply u times u to the power 6, same basis multiplying, that just add the powers, u to the power 7, then 2 times u to the power 6, that is going to be 2u to the power 6, and then we've got a du. So from this point simply get to integrate the integral of u with respect to u. That would be u add the 1 to the power and then divide by the sum, and then plus 2 add 1 to the power and then divide by the sum. Simply add the constant c. So here we can see that u to the power 7 is common, so I can remove u to the power 7, but we already have a 9 down, and we're going to remain with only u over 8 and then plus 2 over 7, since we've removed the of u to the power 7, and plus a constant c. I can as well now just replace where there is u. We said u is this thing which is inside, so 3x minus 2 to the power, this is power 7, divided by 9, and then we have got, where there is u again, we're going to put 3x minus 2 divided by 8 plus 2 over 7 plus c. We can simply simplify this one more, and that is going to be equal to 3x minus 2 to the power 7 divided by 9, and here 7 multiplied by this thing on top, that is going to be 21x minus 14, and then 8 multiplied by 2, that will be 16, and then in the denominator what are we going to have? So we're going to have 8 multiplied by 7, which is a 56. And so this gives us 3x minus 2 to the power 7 divided by 9, and then you have got 21x, 114 plus 2, that is a positive 2, and then divided by 56, then you have got plus c. So we can simply multiply those which are in the denominator. We have got a 9 multiplied by 56. So that will give us, and I can remove it, that will be 504. Then we remained, we've got a 3x minus 2, that is raised to the power 7, and then we have got a 21x plus 2 is just going to remain because we multiply 56 by 9, then a constant c. So that is going to be the integral for this one. Evaluate the integral. Now for this one, it's supposed to be a definite integral. We've got 2 and a negative 1 there as a limit. So how do we get to integrate that? In the same way, you can see we've got linear factors which are multiplying. So I'm going to get this which is raised to a power and equate it to a certain letter, just n letter. So let's u be equal to 2 minus x. So if I differentiate, du is going to be, the derivative of 2 is a 0, derivative of negative x is a negative 1. But we're supposed to have also dx, but negative 1 dx is the same as just negative dx, because so it was supposed to be du over dx is equal to negative 1. So multiply both sides by dx, and making dx subject the formula, dx is going to be equal to negative du. Simply divide both sides by negative. We are going to make x subject the formula. I'll take x this side, I'll take u this side, and so u is going to be 2 the x goes the other side, so it becomes x is equal to 2 minus u. Therefore the integral between 2 and negative 1, we'll say where there is x there, we're going to replace. And what are we replacing in this case? Where there's an x, we are putting 2 minus u. And then there's a plus 1 which is here, and then where there is 2 minus x, we are replacing u, and that is raised to the power 4. Where there is dx, we are putting negative du, and this, we can simply take this negative in front of the integral, so that it will be negative the integral of 2 negative 1 and 2 plus 1, that is a 3, then minus a u. We also have u to the power 4 outside, and then du. So what we are going to get from here is negative the integral between 2 and negative 1, and what we are going to have is 3 times u, that is going to give us 3u to the power 4, and then negative u times u to the power 4, that will be negative u to the power 5, and then du. So from here I can as well simply swap the limits, but I can even leave it them just like this. Now notice one thing here which I've not done. We said let u be equal to what? 2 minus x. So these are the limits we had when we had x, but we no longer have x, we have u. So what are the limits that we are going to use when we are using u? So we're going to say u is equal to, for the upper limit, when x is equal to a positive 2, this will be 2 minus 2, which will be equal to 0. So we're going to put a 0 there. And when x is a negative 1, the lower limit, it will be 2 minus, where there is x, put a negative 1. So always change the limits when you change the variable, and that will be a 3. So that will be the lower limit, a 3. Now whenever you have a negative here in front and then you've got the limits like this, you can as well swap the limits, and then the function becomes positive. The 3 goes on top of the 0 down, and then you have got 3u to the power 4 minus u to the power 5 du. So the negative is no longer there because the limits have swapped directions, and this is going to be the integral for 3u to the power 5 over 5. We simply add the 1 to the power minus u to the power 6 over 6. Upper limit there is the 3, lower limit is 0. So substitute the upper limit, that is going to be 3 to the power 5 over 5 minus 3 to the power 6 over 6. Okay, we're supposed to say minus, we substitute the lower limit, but if you get to substitute the lower limit, everything will give us a 0. So actually there's even no need of doing that. Okay, so from this point we'll simply get to simplify 3 to the power 5, that is a 243, and we're multiplying that by a 3 which is in front there, which is a 729 over 5, then minus 3 to the power 6, that is a 729 over 6. So what is this going to give us when we work it out? 729 over 5 minus 729 over 6. So that is going to give us 243 over 10. And that is going to be the integral for that one. So the last one here, evaluate the integral of x minus 1 divided by the square root of 2x plus 3. So in the same way we've done, I'm going to get the one which is a bit complex and then equate it to u. So what is down there? Let u be equal to 2x plus 3. That means du is going to be equal to 2 dx. Making dx subject the formula, dx is going to be equal to du divided by 2. So again, I'll make x sub the formula. I'll take 3 the other side. So it will be u minus 3, and that is going to be equal to 2x. Therefore, I'll divide both sides by 2. X is going to be equal to u minus 3 divided by 2. That becomes the integral. Where there is x, I'm going to substitute u minus 3 over 2. And then that is minus 1. Okay, there's a minus 1 there. And then everything over. Where there was 2x plus 3, I'm going to substitute u. Remember that was square root. Where there was dx, I'm going to put du over 2. And this is going to be equal to, I'm going to merge this as a single fraction. This is the same as over 1. So that is going to be u minus 3. This one multiplies with what is there. And then 2 times negative 1, that would be a negative 2. And then divided by 2, which is this 2 here. Since this one is in the denominator, I can as well just write it here. And then you also have du over 2. And that is going to proceed. That is going to be the integral of u minus negative 3 minus 2, that would be a negative 5. And that is going to be divided by, in the denominator, these 2 multiply with these 2, that is going to become a 4. So that is going to be 4 u. Instead of me saying root, I can say to the power 1 over 2. And then du. And so this is going to be equal to the integral of u minus 5. I can remove this because it's a constant. So that is going to be 1 over 4 outside. Then we have got the integral of u minus 5. I can as well say, okay, this is first u 1 over 2. And then du. And this is going to be equal to 1 over 4 integral. I'll split them, u over u to the power 1 over 2, then minus 5 over u to the power 1 over 2 dx. And from here, what are we going to get? That is going to be 1 over 4. When we are dividing numbers of the same base, we can simply subtract the power. So this is power 1. So 1 minus half, that would be a half. So that would be u to the power half. Then minus 5. This u to the power half, I can take it on top. That becomes u to the power negative half. And then dx. Of course, there is integral there. From this point now, we can simply integrate. This is going to be 1 over 4. U to the power half plus 1, that will be u to the power 3 over 2. Divided by the same 3 over 2 minus 5. u to the power negative half plus 1, that will be positive half, divided by the same positive half, and simply add a constant c. And this is going to give us 1 over 4. This 2 which is in the denominator, you can simply take it on top, so that will be 2 u to the power 3 over 2. And the reason for this is because we have got u to the power 3 over 2. This is the same as divided by 3 over 2. And when this sign changes to multiplication, this one is going to go on top, the 3 comes down. So that is why I've written it like that. And even here it will be 2 times 5, which will be a 10, and then u to the power 1 over 2, then plus a constant c. Okay, so from here I'm going to factorize out what is common before I can substitute back what we equated to be u. So we have got a 2 here, we've got also a 2 here, so I'll remove a 2. Then we've got 4 in the denominator. We have got a u to the power half here, we have got a u to the power half here, so I'll remove that also. So what will remain inside, when we remove u to the power half from here, what will remain? So it is 3 over 2 minus half. So we simply subtract this power minus this. It is just a 1 that is going to remain, so it will just be u over 3. Minus, if we remove a 2 from here, what will remain is just a 5, because this one has gone already. Then plus a constant c. And from this point now we can direct substitute back. And that is going to be 2 over 4. This is the same as 1 over 2. Then we have got u the power half. So let me put back u. Remember we equated this which is in the denominator to be u. So that will be 2x plus 3 to the power half now. And then the same 2x plus 3 over 3 minus 5 there, and plus a constant c. And this will give us 1 over 2. I can as well write this as root of 2x plus 3. And then what we're going to have there is, this is the same as over 1, cross multiply 2x plus 3, this times this, negative 15, then over 3, plus c. And this is going to give us 1 over 2 square root of 2x plus 3, and that will be 2x, 3 minus 15, that will be a negative 12 divided by 3, then plus a c.